welcome to Just Learn. In this video, I'm going to teach you types of chemical reactions. But first, I want to tell you what a chemical reaction is. A chemical change takes place when a chemical reaction occurs. In a chemical reaction, new substances are formed. The substances that undergo chemical change are called the reactants, while the substances formed at the end are called the products. I'll just take note that some reactions occur naturally even with our knowledge. Not all reactions are carried out by humans. Some are also carried out by plants, like in the process of photosynthesis, where carbon dioxide reacts with water to form glucose. And release oxygen, and at the same time it creates energy for itself. I'm just going to denote energy as E for this reaction. Now we're going to balance it. This is a type of reaction that occurs on its own. It's carried out by plants, usually in the process of photosynthesis. Note that there are different types of chemical reactions. In this video, I'm going to be focusing on 4 of those types of reaction. The first type of reaction is a combination reaction. This is a reaction with an element. I want to denote element as E, or small letter E rather, which an element combines with another element to form a compound. This is just a brief outline of what a combination reaction is. It is also when a compound reacts with another compound to form a bigger compound. Note that in a combination reaction, only one product is formed, as we can see from here. When an element combines with another element, it forms a compound which occurs in a combination reaction. But when a compound reacts with another compound, it forms a bigger compound in a combination reaction. Now I'm going to give you examples of this type of reaction. First, we have iron. Iron in a solid state reacting with sulfur, still in a solid state, to form iron 2 sulfide. Which is also in a solid state. Now in this case, iron, which is a compound, reacts with sulfur, which is another compound, to form iron, which is an element, combined with sulfur, which is another element, to form a compound. Sorry for the mistake. Another example of a combination reaction is the reaction between zinc and chlorine. Zinc in its solid state reacts with chlorine to form zinc 2 chloride. Remember that chlorine is diatomic. 2 at the end of chlorine. Chlorine is a gas is in gaseous form, and zinc chloride is aqueous. This is AQ. Now I'll show you a video to illustrate this reaction. Basically, for a combination reaction here, we have iron reacting with sulfur to form iron 2 sulfide. The second type of reaction is a displacement reaction. In this type of reaction, an element or a radical displaces another element or radical. Examples of radicals are SO42 minus, trioxocarbonate 4 ion, and even the ammonium ion. Now, another name for a radical is a polyatomic ion. I'm going to write some equations to illustrate a displacement reaction. An example is the reaction between zinc in its solid state plus hydrogen chloride or hydrochloric acid. Hydrogen chloride is the gaseous form of HCl, but in this case HCl is aqueous, not gaseous, so it's referred to as hydrochloric acid, and this will form zinc chloride and liberate hydrogen gas. Now note that the zinc chloride will be in its aqueous form also. Now I'm going to illustrate this equation with a video. Now I want you to note that the colors I use in the video for the chemicals may not be the real colors in real life. It's just for illustration purposes. So now from this setup, you notice that zinc will react with hydrogen or hydrochloric acid to form zinc chloride, and hydrogen bubbles will be liberated. Now, these hydrogen bubbles is what have been displaced from the reaction I gave you before. Another example of a displacement reaction is the reaction between chlorine and potassium bromide. Please pardon my writing. Now this will form potassium chloride and liberate bromine vapor. Now I'm just going to balance this equation. Now, note here that chlorine displaces bromine in the reaction, and it takes the place of bromine in potassium bromide to form potassium chloride, and bromine is liberated. Now let's go to the third type of chemical reaction. The third type of reaction is a decomposition reaction. From the name, it implies that this is when a substance decomposes into its constituent elements. By substance, I mean compounds. And note that it involves a single compound decomposing. If this reaction is caused by heat, it is called a thermal decomposition reaction. Note, thermal decomposition reaction. Now I'm going to illustrate one of these thermal decomposition reaction. It involves lead nitrates. Now, lead nitrates in the presence of heat is going to decompose and form lead 2 oxide, is going to form also nitrogen 4 oxide. Now this 4 written at the front of NO2 is for the sake of balancing the equation, and it's going to also form oxygen. Now lead nitrate is in its solid state. Now when heated, it forms lead oxide solid state, NO2 gas and oxygen gas. Now to balance this, I'll just add a 2 to PbO, and yeah, it's balanced, and 2 to lead nitrate. Now I'm going to illustrate this reaction with another video. Make sure you take note of how the lead nitrate decomposes in the video. Now, lead nitrate in the presence of heat is going to decompose, as you are going to see, decompose and form lead oxide, and oxygen and nitrogen 4 oxide will be liberated. What it takes place in the presence of heat. The fourth type of reaction for this video is a reversible reaction. A reversible reaction is a reaction that can go in both ways. That is, the reactants form the produce, and the produce can form the reactant. It can occur in opposite directions, provided that the conditions necessary for those reactions are met. An outline of this type of reaction is, for instance, I can say an element A plus react with an element B. Now it's going to form C and D. Now C and D can also react to form, sorry about my lines. C and D can react to form A and B, so it can go both ways. Sometimes heat could be necessary for the reactions to occur, or sometimes heat will not be required. But as I've said before, the conditions required for the forward and backward reactions must be met. Now another example is, I can say A plus B plus C can react to form D, and D can decompose to form A, B, C. I can also say that A plus B will react to form C, and C will decompose to form A plus B, or A and C rather. Now note that this is the symbol that indicates a reversible reaction. Now I'm going to give you real reactions that illustrates a reversible reaction. So from this reaction, you can notice that steam is going to follow a pathway into the iron, and it's going to react with iron. to form triion tetraoxide, which you can see in this first conical flask, and hydrogen gas liberated is going to form in the second conical flask. Now, if we are to create a pipe, for instance, that could run back to the first conical flask, hydrogen will go back and react with triion tetraoxide and is going to form iron and liberate steam. In a way, you can see that the entire reaction has been reversed. For the first chemical equation, we are going to have nitrogen combining with hydrogen, which is also diatomic. And this is going to react to form ammonia, which is NH3. Please pardon my handwriting. Now, ammonia can dissociate, or should I use the term decompose, or form its constituent elements, which is nitrogen and hydrogen. Another equation to illustrate a reversible reaction is a reaction between calcium hydrogen triacylcarbonate 4 Now, this will form calcium carbonate is also going to form water, and finally it's going to liberate carbon dioxide. Now note this is solid, liquid, and gaseous. The calcium hydrogen triacylcarbonate 4 is aqueous. Now, this is a kind of decomposition reaction, but it's also reversible, meaning if these three should combine, it's going to form calcium hydrogen triacylcarbonate 4. Now, when this decomposes, when what we have here decomposes, it forms calcium carbonate and water along with this, but these two are going to come out as a suspension. A suspension is like, for instance, you put a solid in a liquid, but that solid does not dissolve. You can still see particles of the solid inside the liquid. That is what a suspension is. So when this decomposes to form a suspension of these two, and CO2 gas will be given off. Now for the third equation, I'm also going to illustrate it with a video, but first I'm going to write it down. Iron in its solid states going to react with steam. We know H2O to be water, but since it's in its gaseous form, it's steam. And it will react to form Fe3O4. And liberate hydrogen gas. Now the IUPAC name of Fe3O4 is triion tetraoxide. Triion tetraoxide, because there are 3 atoms of iron and 4 of oxygen, so it's triion tetraoxide. I'm going to illustrate this with a video, but first I'm going to balance this equation. So it will be 4 moles of hydrogen and 4 moles of steam and 4 moles of hydrogen. Thanks for watching. Please don't forget to like and subscribe to this channel, and please support my channel so I can make better videos. Thanks for watching.